Welcome everyone to a new session of San Diego C Meetup. This would be our 18, if I had my count correct. So about a year and a half. I think we lost only one time in March, so it's 18 since the first one. Just out of curiosity, how many? I see 30 people. How many people are new to the session? If you can raise your hand. Okay. So welcome. Since there is more than one, actually more than zero, at least one that is new, I'll go over the goals of the meeting, what we want to achieve. So this is your 2 hours in a month that we can discuss anything that you can think of related to C++. You can bring any question, code review, any book or article or blog that you've seen and you want to discuss. So if you want to present something, it can be any length from 10 minutes to an hour or more. Please let me know and we'll work together to get you on the next agenda. And as I mentioned before, and I'll mention it again, the idea is that you don't need to be expert in order to present. You'll be familiar with the topic as you prepare it, and we can start with something small. You don't need to prepare something for 1 full hour. It can be something like 15 minutes, and there's a lot of things that we can do and present in just 15 minutes that could be useful for others. So so that's one thing, and yeah, please approach me. It can be informal. The idea is really to have fun and improve our knowledge in C++. And I know that I learn a lot every time I present something and I hear discussion. So so please let me know if you want to present. Our agenda structure is usually I would have about almost 1 hour or maybe less of kind of a miscellaneous. I'll pick a specific GitHub repo. Actually, it can be also GitLab. I don't know why I had GitHub only, but just lots of stuff happening on github.com. And I'll present it, and hopefully it's useful for others on their day job and or hobbies. And I'll cherry pick a lightning talk that can be interesting for us. And that would be a kind of a recorded. I have I think this time it's like 2 minutes from CppCon 2019, I think, if I'm not mistaken. Again, I'm preparing the slides few weeks, like 3 weeks ahead of time. So then I pick a simple LeetCode question and I present my solution. It doesn't have to be the best solution, but the reason I'm presenting it is because there's few elements in the syntax that I want to present, and maybe it's going to be a new syntax for others that they can learn from. I'll cherry pick a C++ Stack Overflow question that just happened to be on my Twitter feed, and it looks interesting for to share with others. And then few questions from C++ quiz website. So there is a website named C++ quiz, and I picked three questions this time, and we'll go over the questions. And it's pretty much fun to solve, and you can learn a lot. Then I have a C++ or something related. So I even bought a C book before. Some book recommendation that I feel would be useful for you to pick and read. It can be something that you can or should read cover to cover, or just a reference. This time around, it's a C++ standard library quick reference from Apress that I highly recommend, and I'll talk about it when I get to the slide. And this meeting, we'll talk about Lambda, and I see it like a workshop where I hope that everyone attending that or watching this the recording, once you at least the first part, I don't think we'll be able to finish the whole thing today, but at least the first part would be kind of demystifying the whole Lambda thing, and I'll hopefully, my plan is to make it very simple for everyone to understand like what it is and all. And there are a few Qualcomm employees that requested such tutorial or workshop, and this is I took this opportunity to present something which is like from 0 to 60 in at least the first part would be very useful for you if you have no idea how it works and all this magic of Lambda and all. I'll completely demystify it and make it very, very simple for you to understand, hopefully at least. So before I go to my next slides, is there any question? Anything? No. Please feel free to stop me. Just unmute yourself and ask question. It is an interactive session, at least designed to be interactive. So by all means, feel free to stop me. Okay. Thank you, Qualcomm. I'm employee of Qualcomm, and Qualcomm WRD, which I'm part of, WRD software, wireless research and development, is sponsoring our meetup fee, which I basically paid this week, by the way, for the next 6 months. So thank you, Qualcomm, for that. We have a Dropbox link that I'm placing everything. And by the way, in meetup.com, in our page, all these links, they are listed in the welcome page. So you don't need to memorize anything. So there is a Dropbox link. There is a Slack channel that it's kind of dormant. It's not really used a lot. I'm always there. Like my Slack channel is always open if you need anything. We have a YouTube channel that I'm uploading my sessions every month. And I started uploading it just a few months back. So we don't have the full history, which is fine. We can always refine and repeat something that we had before, which in the beginning that we didn't. Actually, the Lambda one is sorry about the dog. The Lambda one is something that I had maybe on the first or the second session, but it's much more improved and thorough than the previous one that I had. We have a Twitter account that I manage as the CppMU. MU stands for Meetup, and my handle, my Twitter handle is Kobe_CA. And if you want to follow me, I tweet a lot about C++, Linux, software engineering, also a bit about Rust, a bit about Python, functional programming, and everything in between. So feel free to follow me. I tweet a lot, so we get a lot of data. Okay, so if there are no more questions, I'll start with the GitHub repo of the month. And this time I picked something very useful, I think, for a lot of people that I've seen that being used in many projects. And this is the Json for more than C++. I don't know if you heard about it or not. I think this is something that is commonly used. I think the number of stars is like insane, and I'll take this opportunity to talk about Awesome C++ website that you can subscribe to the newsletter. I think it's once a week. You'll get kind of a digest of the weekly articles about C++, like the best one that people published. If you follow all these folks on that they are from the community, from the C++ community, you'll get the same data. But this is kind of instead of being distilled, this is the one page every week. Sorry, every month. So yeah, every week that would have all of these important articles. And the nice thing about that is that you see these featured libraries. So they have, and it's going to repeat itself, all kinds of mostly C++ libraries that solve a specific problem or domain. And I find it very useful. I don't know if this is the one that I'm actually. This is not the one that said something else. So I picked up something from like previously from previous newsletter. So I suggest you, if you really want to be up to date with what is out there in terms of C++ libraries that you can use, look at the license. If you bring it to your company, obviously look at the license, see if it's permissive. But I found it like the best resource for me to understand the landscape of the library, the useful libraries out there. And this library that I presenting today, this Json library, was taken from it has like 20,000 stars, which I think, looking at this image, when I took this image, like print screen, I see like 19 dot something. So within a few weeks, it's already up. So this is a very useful. It has like a nice DSL-like syntax that you can write a JSON string, and it's being loaded and parsed automatically. Yeah, this is a GIF, so it's gonna transit to all kinds of examples. Highly recommended. Very super stable. 20,000 plus stars. Yeah, so you see that this is like a nice DSL. You write it, and that's it. You have a JSON object, C++ object that you can poke around and serialize, deserialize, all of that stuff. Very, very nice and useful. Anyone using this library out there?
We did explore this, and we are also using this RapidJSON, which seemed to be an equivalent thing, which was interesting.
Yeah, there is RapidJSON, SIMD-JSON, there's all kinds of them. And yeah, if you just go over this website that I mentioned, you'll see a bunch of these, and just pick the one that looks good for your use case and for your project. And I think I can't remember if this one is a header-only library or not. I just can't remember. I think it was a header-only, but I can't remember. Okay, so might be it's just a single header, single JSON header. Yeah, it's header-only. By the way, there is awesome HPP. So this is awesome CPP, right? There is also awesome CPP, HPP, that they have a full, I don't know, let me see if I can search for that for a second. Yeah, awesome HPP. So this awesome HPP has a bunch of Git repositories that are all header-only libraries. And very useful, by the way. It is partitioned to domains, and it's huge. Yeah, you can see that. So obviously I have that starred because it's very useful. It's I think it came up just recently. So it's a new Git repository that has all these nice links to other header-only repositories. So so Json, for example, you can see all of these. So someone mentioned rapid Json would be this one. This is nlohmann Json. I don't know if I butcher the name or not, but this is basically, and the nice thing, you can see the license, the description, the stars is actually nice. You can actually see how common and how much being used. Stars is usually kind of give you some first order of how much it's being used. So you can see that I think this one is 20K, SIMD is 12K, so it's pretty decent. Yeah, you very useful, by the way. So hopefully you can find it useful as well. Your questions? No questions? Okay. Yeah, raise your hand. I'm checking the team meeting once in a while just to make sure that. Okay, lightning talk. So in order for that to work, I think I need to. Last time I think that what happened. I need to reshare my entire desktop with audio. 1 second, okay? So this is from CppCon, making sense of terrible template errors. If you had an error with templates, very long one, you'll appreciate this Python repository written by Vittorio Romeo. Okay. You should be able to hear that. Let me know, just shout if you can't.
Okay. So this is a script I wrote, and I was inspired in showing this script to you from one of the talks, lightning talks we had on the first session. So somebody showed, I think it was Marcin, an error like this. When you have some sort of code which is heavily templated, and you're trying to do like tuples nested with other tuples, you get some stuff like that. You can read it, but even if it was zoomed in, you couldn't read it anyway, and that's the main problem. So what my script does is it basically goes through this kind of errors and collapses the templates for you. So if you have something like a super nested template, a tuple inside a tuple inside a tuple, you can specify a depth, and it's going to do some text preprocessing to collapse the template to something a little bit easier to read. And the benefit of that is that then you can go up and down this depth because it caches whatever was collapsed, like in this case over here. And as an example, if you have like this super nested type, if you go with depth 0, it's going to show you only the top level type. Then if you want to keep going that, you can do depth 1, and it's going to show you the second depth and so on, which is quite useful to understand why this error is happening or what's going on. I've used this with Boost HANA and Boost MPL, and it helps when you have this kind of very weird, complicated template errors. The other thing is you also specify some regexes. So if your error is very big and you don't want to see a std vector all over again, you can elide std or alias Boost HANA to BH and stuff like that, which also helps the readability. Or also have some regexes for stuff like forward or lambdas to make them shorter as well. So the way you use it is that you just redirect your output into the script. The script is going to cache the error message that you get, and then you can run the script again, reprocessing, for example, to play around with the depth without having to recompile your code. So you start with depth 0, you see the top level error, and if you need more context, you can increase the depth and go up and down the template stack, basically. A bunch of configuration, stuff like that. It's just a simple Python 3 script. And in general, the benefit of this is it converts this huge mess into that one, and the relative size change between the output of the compiler can be very significant. So if you are using Boost HANA, Boost Fusion, or stuff like that, feel free to try it out. It's called Camomilla, and it's available on my GitHub. That's it.
So yeah, Boost HANA and Infusion, they are a beast. So if you working with such heavily template metaprogramming ones, so you might find it useful. Okay, let's I'll reshare 1 second. Give me a sec. Okay. Hopefully you see my screen and move to the next one. Do you see it? Do you see the better algorithm intuition?
Yes.
So just to repeat, this part of the San Diego C++ meetup is inspired by Conor Orchestra, which by the way has a the CppCon 2020 is happening this month. Unfortunately, like everything else, it is virtual conference. So he would have a session, a talk planned for this for the upcoming CppCon 2020. As I mentioned before, highly recommended to watch his past talks in multiple opportunities that he had in multiple conferences, CppCon 2019 and in other conferences. Just Google his name on YouTube and you'll have it. And the idea is really to try and map problems to existing algorithms, very oriented towards functional programming, and the idea is really just like we have this, like we developed over time. We as engineers, we developed this intuition about data structure. So we have a problem, we know complexity that we need for this specific use case, complexity of our data structure and all. So we know that, oh, we need to pick stud vector, or we need to pick some binary tree, like stud map, or maybe a hash map, like unordered, maybe a map, maybe a set. So just like we have this intuition, of like we develop this intuition about picking the right data structure. The idea is that we should develop intuition about picking up the right, I would say, like algorithm or functional programming style to solve our problem. And of course, there is no just one, not always just one single algorithm that you use. Maybe a combination of algorithm. You need to maybe sort and then filter and then map, which is transform in C++. Then you have something that you can use as the full solution. One day we would talk about C+20 ranges. It's kind of a more, I see it as a more advanced. So we'll talk about it in the future. But C+20 ranges gave us a better syntax and some lazy evaluation and all of that. If it tells you not, if it doesn't rings a bell, or don't worry, we'll talk about it in the future. But it provides us a better way to handle functional programming style. So this time it's kind of a very common question. Giving a number, how do you know that is a polindrome? I don't know if I pronounce it correctly or not. So if it's a negative, it's not, and this is false, and so on and so forth. So I'll show that there are two solutions. One is using string, and one is using just integer, not using string. And I'll focus on the string one, and the one with the integer. If we have time today, we'll talk about it today after the Lambda. I doubt it, but I have the solution on GitHub, and there are links for that to Godbolt. And we focus on the string part, since the string part has also some things that I would like to kind of talk about. So what I'm going to do is I'm going to delete. So this is the solution, and I'm going to delete everything that has nothing to do with the first solution, which is okay. So there are just two things that I want to show, maybe three things in this solution that might be new to some people, that maybe it's their initial engagement or working with C++ is they're kind of new to this to the language. So this is the function, and the idea, the reason it's behind class versus just being a free function is because LeetCode was mandating that. So I just, in order to just copy paste, I kept it. I just put it as static because there is no state to the class. Again, don't worry about about this stuff. We'll focus about the solution for now. And I'm passing. So there is this integer that I'm passing, and there are two checks. First of all, I'm passing it by const because I'm not going to change this integer. I'm actually using it once, and that's it. And if it's small, if it's negative, it's false. If it's just one number, one digit, we're all good. And this is the beef of that. So C++ 17 has this toString. By the way, I don't know if you're familiar with that, but in godbolt.org, relatively new, maybe a couple months, if you right click, you can have search on CPP reference. I don't know if you knew about it, and you can take a look. Oh, and this is C++ 11, by the way. I said 17, but this is actually 11. I'm compiling for 17, but this is specifically 11. Okay, and I have this string returned by copy. I make it const because I'm not going to change it. I'm just only going to look and traverse the string. And I'm using the constant end iterator going backwards, and the constant begin moving forward. And the reason I'm using constant is that I'm only changing the iterator, but I'm not changing what the iterator is pointing to. So I'm not changing the string. Now, before we look at this while, which is, you can see it's pretty simple. People might ask why you're not using CBegin and RBegin. Like RBegin would give, or CRBegin. C stands for const, R would be reverse. Because I cannot mix, if you try to mix CBegin with RBegin, there are two different types of iterator, and I cannot mix between them. So I cannot have this less than operator. So if you had this question about, oh, why can't you do just CBegin and RBegin and CRBegin, they cannot, they're not the same type. So the idea is just to go to traverse from the beginning to some point until, and the end from the end to some point until they either the same, or as long as the forward one is less than reverse, we can check. And the idea is that we want to check that the characters are the same. So what I wanted to, there are two things that I wanted to show here. One is prev and one is advanced. So Yeah, you could use plus plus or minus minus on the iterator, but I wanted to show this syntactic sugar of that exists in C++. So if you look at std_prev, it has the iterator that you want to change, and how many steps, and by default this is 1. Not very common, I think, to see a default parameter, by the way, in the standard library API. Just as a side comment. So I just want to have a prev of 1, so I'm getting the reverse minus minus, and so initially, when I point to the reverse, it would point to the one past the it points to the stud end of str, which is one past the last character. So first of all, I want to bring it. So that would be the first. So I want to bring it to point to the last one, and then I'm comparing. The moment they are not equal, this is not what I'm looking for. Otherwise, I'm advancing forward with advanced prev and continue to check. Stud advance, again, this is kind of a syntactic sugar, and it also has this distance. As opposed to stud prev, this one takes the iterator by reference. So it's kind of confusing, and this is why I wanted to show. Std_prev has also stud next. Both of them, prev and next, would return the iterator after the either minus minus or plus plus, depends of what you're looking at. Stud advance would be giving you, but we would be using the parameter as a reference, and this is what you'll get. If n is negative, the iterator is decremented. So this is why you see this legacy bidirectional iterator, so it can go both way. So advance can be advance forward, or if the distance is minus or is negative, so it would be backward. And here what I do is just 1. There is no default parameter. So it's kind of strange. Initially, you need to remember that stud next and stud prev they have a default parameter of 1, and they return the iterator versus advance, which is doesn't have a default parameter, and it takes the iterator by reference. And that's about it for the leetcode. I couldn't map it to stud algorithm. I tried, and I found it a bit cumbersome, and I felt like a simple while loop is good enough. And I think the amount of code here in the loop is sufficient to understand. But if you have a better idea how to make it a stud algorithm, let me know, either through Slack or other means. Sorry about it, 1 second. That was evacuation order. I don't know which area, but I got them like this. My phone just had this, at least the last few sentences that I heard was about the evacuation area, and I don't know. Hopefully it's not Rancho Penasquitas where I'm broadcasting from. Okay, let's go to the next one. Any question, by the way? Just want to make sure that no one has anything. Okay. So let's go next. So the next one would be the Stack Overflow of the month. And okay, take a look at this. There is a function, static one, that takes basic istream of unsigned character by ref in. And there is a string read. And so the person posting this had these two calls: do something with file and do something with str. And there was an error. This is on MSVC. I'm just looking at the error code. I think it looks like MSVC. Cannot convert argument 1 from istringstream to basic istream, which is kind of weird. If you look at that, the person just wanted to create a string, and it takes an in parameter. And I think what he or she wanted to do is to cast this unsigned character with basic strings. Okay, so this is basic string, basically std string, and I think what they wanted to do is to cast it, and then so to cast it, create an istringstream out of std string. Sorry, there is this thing happening again. 1 second. Give me a second. Sorry, I needed to keep it silent. Okay, so going back to the Stack Overflow. So what is actually the issue here? So let's take a look at Goldbolt. Anyone want to guess? Okay, there is maybe a guess. Okay, so anyone want to have a guess about why there is this issue? And let's take a look at so this is the code, and I cannot call it. If I call it, there was going to be an error. There is a warning, but can anyone think this is stuff, but it happens a lot. Okay, so take a look at this. This is a function, right? This is a function f, just a definition of function f that takes an int and have an argument I, and for some reason there is a parenthesis just wrapping this I. So let's take a look at what CPP Insight does. So this is the code. So CPP Insight is a very useful tool that and there is sorry. There is a button here in CPP Insight in Goldbolt compilers for that. You can have this code pasted, and then if you play, so take a look what happened here. So this function, the parentheses went away, so they are meaningless. So if you have parentheses, it's basically just goes away. So take a look at this. It is basically just as if I would write and take a look at this line and tell me, what do you think this looks like? There can be two options here. Okay, one option, and I just defining string of type basic istream of unsigned character, and I'm trying to do something here. I'm passing this basic string, which is toString. I try to cast it, but actually the compiler actually sees that differently. So this actually looks like a function call to the compiler. So this is what we call most vexing parse, which is if something looks like a function call, the compiler would treat it as a function call. And this looks a function call. And what is the function call here? The function name is str, and it has one single parameter. It has a std basic string, unsigned character, and the name of this parameter is in. The type is basic string, and the name is in. And it returns std basic istringstream. And this is the issue here. The parentheses are kind of confusing, and you think, yeah, you're casting it, but it goes away, and the compiler sees that as a function. And since it looks like a function, and what you try to do here, if you think about it, when I try to call do something, it will try to take this function and pass it here, which doesn't really make sense. So what's the fix for that? And if you look, by the way, if you look at the warnings, this is why I actually have, if you look at the warning, you'll see something like this. There are this ambiguated as function declaration -w vexing parse, and add pair of parentheses to declare a variable. In addition to this, you can just should be able to do something like this. This should work. I'm not sure. I can't remember. I have the solution somewhere here. Let's see. Oh, it's the same one. Okay. So just the curly braces around the whole expression. I don't know what I'm missing here. 1 second. Oh, undeclared. Okay. Okay. Oh, this in is actually undeclared because of the main one had in here, and I missed that. So what we're gonna do is just copy paste the whole thing, just to see the full. Might be missing. I think it's istream, if I'm not mistaken. Can't remember. Okay, so yeah, there is no main, so it just was missing. Maybe in the other one it was also just missing the header, but just unused function. But anyway, this is to disambiguate the function declaration. parentheses is needed. And this is basically, if you see the vexing powers in the warning, you know that you're using parentheses instead of curly braces. Okay, let's see if there are any questions. Oh, the recording would be shared on YouTube. There is a channel, so someone asked. Okay, let's get rid of all of these so you can see stuff. Okay. CPP quiz. This is fun. Let's start the first one. So difficulty is medium. CppCon 17 is mostly CppCon 17 standards. What is the output of this? So we have an integer, and we're taking the max. So in C++, we have numeric limits, which are zero-cost abstractions to retrieve all kinds of limits of different types: integer, floats, double, unsigned integers, uint, 8, 32, 64, you name it. There is a max, there is a min. Super useful, by the way. If you look at the numeric limits, you should be using it in your code instead of hard coding any magic number. So get yourself familiar with that. Very useful, and it's all templated, so it's zero-cost abstraction. It's compiled to the actual number, and that's it. Float and double, they have like these special things like lowest, sorry, and infinity, and all of that would be important on floating points. Okay, so numeric limit takes the maximum of the integer and put it into I, and then we plus I. So what would be the value printed? Oh, and the options is there is guaranteed to output, or compilation error, or it's implementation or unspecified, or it's in undefined behavior by the standard. And you can shout your thoughts, and it's okay to get it wrong. It's hard.
You're going to say maximum value of whatever the system representation of an integer is.
The maximum value. So, but we already here in the maximum. Yeah, maximum. Oh, you mean of
right.
if it's, let's say it's uint 64 would be the width of the architecture, like it's M64, the architecture is 64-bit, so the maximum. Okay, which I don't know what the number is from the top of my head. This would be like uint 64 max. Any other thought?
I'd say undefined behavior.
Undefined why?
Because it's integer overflow.
Integer overflow. Okay. So and wraps. Okay, we actually have three good answers. Either it wraps around, or it's give you like a very high number, and or undefined. So C, this is coming from C, and C++ kind of following that path is, though it's gonna give you like I think 2 complements and all, this is an undefined behavior. So the reason for that is there is no really a wraparound defined in the standard for signed types, signed integer, for example. And there's a reason. If you Google for that, like long time ago, I was curious why that's the case, why we don't have that. And the reason is that just kind of recollecting, the reason is that machine can implement negative numbers in all kinds of ways or techniques. two complement, I think, is one of the most common, but it doesn't mean so. The C standard didn't want to dictate, oh, this is gonna be like a wraparound and this is gonna be the value and all of that. So they kept it undefined behavior. So let me just click on the answer. And few things that I would like to mention here. One is in my programs, in my C++ programs, I try to stick to unsigned integer as much as possible. And there's multiple opinions about unsigned versus signed, good or bad. I'm kind of following Dan Sachs. He had this very good, I don't remember if it's C++ dive or dive C++, I can't remember. So if you Google for his talk, Dan Sachs about integers, he has a very, very good talk about all of this subject, and including numeric limits and all of that stuff. I learned a lot from that talk. And so there's multiple opinion. I stick to having unsigned. One reason is that I don't have, if I just happen to have this wraparound, so if I have this numeric limits, if it's of unsigned, if it's wraparound, if I did this numeric, let's say auto, okay, let's have that. So if I have, let's say, int, and let's have auto. Doesn't need to be const, just yeah, I can't have it const actually. Okay. So this would be fine. This is defined. This is 0. Okay. This would compile as well. But it is undefined, and I don't know if there is a way. Let me take a look. Just now, I'm kind of curious if I add PVS Studio. Let me see. Okay, PVS Studio didn't find anything. Let's see if Tidy would do that. Let's remove PVS. I don't see anything from Tidy. Sanitizer, I don't know. I don't remember if there is sanitizer here. Can't remember if there is a sanitizer. But you can add sanitizers, and sanitizer, undefined behavior sanitizer would catch that. Easily it would catch that. So so I'm using unsigned as much as possible, first of all, to get rid of this, which means that my interfaces, if I need to return a number and I need to return nothing, so I'll use std optional instead of having to need to return an integer, a signed integer, to signal the caller a -1. And then if I use integers, I'm basically start dealing with mixing integers with unsigned integers, and it's a hassle. So I try to keep my ecosystem as much as possible. If something needs to be unsigned, I'll make it unsigned, and I'm not going to deal with signed integer. Only if I really have to, if the semantic requires signed integer. So this is, and I'm kind of following a bunch of other people in the community that has the same approach, but you might have a different one. Another thing I wanted to mention is that there's limits, and there's also C limits. I just want to mention that as well. And C limits would be all this stuff, all these macros. Don't use C limits. C limits is the C++ limits.h. Don't use C limits. Use limits. I know it's confusing. Dan Sachs has the same couple slides about limits, C limits. Use limits. I know there's limits or limits.h, and there's C limits. I know it's confusing. I'm just the messenger. Use limits to request all this numeric limit stuff. Okay. Okay. Any question? Let me see. Nothing. Okay. Next question. Okay. So CppCon 17. Again, this is easy. What's the output of this code? So we have a stud map. By the way, this is a kind of a bad habit, in my opinion, even in CPP files, not to mention HPP, but even in CPP, if you really want to do that, either do it in a very small scope or have using stud map if you just, or using stud cout if you want to have your code more like a shorter one. But my opinion, and kind of following other big names in the community, don't use it even in the CPP scope. Okay, so I can have this MB. So okay, so there's a map of Boolean to int, and I have these 3 elements. So the map is populated, right? And there is a size. And then I have an int to int, different map, again populated with three elements. So the tree would have X number of elements. Here it's going to be again X number of elements and the size. What do you think the size here? What do you think the size here? Again, the difference is the Boolean and integer here. First of all, is it defined? Is it okay? If yes, what is going to be output? Just scream the result. And someone says about CppCon standard folks actually prefer signed. I don't really know about it. I know there's a lot of debates, and there is another debate about having S size T return from span versus size T. I hear lots of different opinions. So if you give me Jehan, I don't know if I pronounce your name correctly. Excuse me if I butcher your name. But if you can provide us some quotes and all, so we can learn, let me know. I know that some people, they prefer sign in loops and all of that, but again, following Dan Sachs and others, I personally prefer that. But yeah, it might be kind of a religious kind of debate. Okay, what do you think the program should output? If it's outputting, it might be other stuff. There's all this stuff.
Would it be 1-3?
1-3. Why?
Well, I'm assuming that anything other than 0 is true. So you're overwriting the same value in the first map.
This is correct. So basically, they would be overriding it. So since we have true, true, and true, we'll get just size would be 1. Here we would have 3 of them. So this is 1-3. The thing that if someone is, hey, is it gonna be 1-0, like true 0? I don't know. Do you want to check? Let's check just for fun. Should be, but hopefully everything is done in order. I would assume. And the output, yeah, we can get rid of Clang and this one and just have the output. Huh, I was wrong. I thought it's going to be 5. It's not actually overriding. It doesn't, it sees that the key is already there, so it's not actually updating it. Which is, now that I'm thinking about it, it match. So one of the API of map, there is insert. There's insert or assign, which is CppCon 17, and there is this operator, which if it probably says that If the key doesn't exist, the function is equivalent to this, to insert. If the insertion is for the map value, okay. Okay, so I think it's insert if the key does not exist, and it's probably a no-op. A no is happening. Okay, so it's a good thing to know. Okay, so the next, okay, I didn't want to do this. The last one would be, according to CppCon 17, what's the output here? So we have a struct that initialize I with 1, another one with 2, and then we have a variant of C and D. Variant is CppCon 17. Think about it like a glorified union. It's not, as far as I remember from Marshall Clow, which is one of the authors of libc++, the Clang version of the standard library. This is not it's not using union. It takes the biggest. It allocates the chunk of the biggest type, and then there is bookkeeping and so on and so forth. So so the question is the following: there is a stud visit. It's kind of an advanced topic, and there is a lambda here that hopefully you'll understand what's happening soon. And so the stud visit gets a callable object. Think about it just a function for now. That this is the body of the function, and something that a stud variant, which can be invoked on this function. So the question is, what would you see? Would you see 1, 2, or is this kind of an undefined or implementation specified? Because we didn't initialize V to be anything, not C or not D.
There we go. 1.
1. Why?
I think strict variant takes the first temporary parameter and default construct that.
Yeah, exactly. So it is defined. If you don't give it anything, it would be initialized with index 0, which is this guy. Okay. Thank you. Okay, so let's move to the next one. Okay, this is a very highly recommended APRES publication book. It's a reference. It's basically holding CPP reference, but it's super good. Like this is, I'm very happy. I have a copy, and it's really my go-to for additional examples other than CPP, what CPP reference provide you. And I really try to challenge this book, and I search all kinds of tiny things in CppCon 17, and this book has it all. Like I couldn't find anything that is missing from the book. So this is something that I hold keeping by my side if I want to have a very quick reference of CppCon 17. Highly recommended. Great authors, by the way. These folks they have multiple books, and I think very good ones. I think Van Weert specifically had more books on C++ that I really like. Yeah, this is my go-to, using go-to Sumi book for quick reference. So, okay.
So I have one question when you are talking about books. Do you have any recommendation for metaprogramming in C++?
Yes, I do. I have a concern that if I tell you everything, like what I have from the top of my head, I'll be missing a lot. My first go-to book would be just 2 chapters of modern C++ design of Alexander Resko. What's his first name? Okay, I can't remember. Yeah, Andrei Alexander Resko. Just the 2. This is a very difficult book. Just the 2 first chapters.
Okay.
Just I read it when it came out. I think it was 2002 or 2003. Changed my life. I'm not kidding. Okay. On the way looking at metaprogramming. But there's other stuff that I can maybe post online. That Justice has a C++ template and there's some STL, very good ones. Not every book would be a good one, but just a few of them that I find very, very good. So look at Justice. I don't know if I pronounce his name correctly. He has a few template books which are very, very good. There are few editions. Just pick the last one.
Okay. Thank you, Gopi.
You're welcome. And the last thing before we go to the main course would be lifetime with stud string view. To put it simple, string view doesn't prolong anything. If you think about it, just a pointer and a length. If your pointer points to a chunk of memory and this chunk of memory goes away, you're pointing to nothing. This stud string doesn't prolong anything. So there is this very common problem that people would return stud string and they'll use string view to view it, and they would try to do something with it. For example, they try to std out. Now, this str function returns an R value that is not prolonged by the lifetime was not prolonged by string view. So when this statement goes away, this first statement goes away, this string view points to a deallocated value. Now, one might be saying, can argue that, yeah, if you have string, small or short string optimization, you wouldn't see it because kind of it's mitigated versus allocating and deallocating on the heap. Doesn't matter. You should not rely on a very short string. This would bite you. So don't use string view to prolong. This is fine. An R value, a const reference to an R value would prolong. The lifetime wouldn't be extended. This is by the standard, so you should be good. Now, a tip: use string view when you pass, let's say, a stud string to a different function as a parameter, and then the lifetime would be guaranteed. Of course, no multi-threading and all of that involved. This is so passing stud string and to a string view function parameter would be something that is probably the best approach. Then you don't need to do any references or copies of stud string, just a simple string view that is really, really cheap. Okay, so I'm going to switch to Lambda. Wait a second, I'll stop this. Okay, Lambda. I think you should know enough by the end of the session or your money back guarantee. Of course, not taking any money from you, but just give you some incentive that you should be knowing enough about Lambda. Please stop me if you have any questions. This is designed to be for beginners, so please stop me if you have any question. Let me see if there is any question. Okay, there. So yeah, let's discuss that. This is interesting. I'll read towards that and we can discuss. I still prefer, even if Bjarne thinks that he would use it was signed. I like unsigned better, but we'll discuss that. Okay. So let's talk about Callable Object. In C++, Callable Object is something very simple. It's a function or something that behaves like a function. Like you can take this object and maybe pass parameters and it's doing something, and then it might return a value. And it's pretty simple idea that you probably know from C and other languages. It's just something that you can invoke. Oh, sorry. And this is basically my own definition. It's like a very relaxed. It can be invoked. You can pass parameters. You can then return a value. This is callable object. And let's take a look at examples. Okay, so we can all agree that these two statements are functions, callable function. The first one is an empty one, doesn't do anything, doesn't return anything. The second one would be returning integer and I don't pass any parameters to any of these. I could, but I don't. And then I can actually have this, there is this notion of function pointers. And believe it or not, I always hated this syntax. This type def, you have this return and then the parentheses where you have this pointer, and this is the name of the type, and then another parentheses to list the types, the parameter types or argument types for this function pointer. And then this function pointer can point this, you can create an instance of this pointer and it can point to a specific function of this type and you can invoke it. In modern C++, if you don't want to use type def, I'm not using type def. I don't remember the last time I used type def. I'm all using, once I have C++ 11 enabled, I'm using. Yeah, sorry for this double using, which is a bit more readable. This is the name of the type, so it's not like in the middle of this whole thing. And then returning this integer in parentheses, I am saying this is a pointer, and this is the parameters. If you want to be even more modern C++, then you can have this trait add pointer t. So return value and parentheses, and it's gonna, these two things, actually all these three things are completely equivalent. They do the exact same thing. This is something that you probably know from C. This is a C++ new syntax with using. And this is if you want to impress your friends and they don't want them to understand your code, because not everyone knows about this type traits. You use this. I'm kidding, of course. Like eventually people would understand type traits. And so yeah, and let's say I have this function, my function that returns 0. And I can create these instances, right? Function pointer 2, which is this one. And I can point it to this my function, and I can invoke this function through the pointer, and I can get the return value, 0 in this case. These two would be equivalent. So either taking the address or not taking the address, it works both ways. And I can take pointer 3, which is this. Pointer 3 is this one, which is the type of pointer 2, and I can invoke that. Very straightforward. All of this is nothing but C or C++ 98 or 03 with just some small new syntax related to C++ 11. Any questions on this one? Should be very straightforward.
I have one question.
Yeah.
What about std function for storing?
Yeah. I'm not today. But if you already mentioned that, there is in C++ 11 there is stud function that would look like something like this. Good, and it's in functional. I'll show, and then I can do something like int. Okay. And I can have my fun. Really quick. I don't wanna, but since you asked, if I'm not mistaken. Okay. So and I can invoke it. I can take stud function. So yeah, there is stud function as another vehicle to use as a function. Holding a function, and you can invoke it. It's another callable object. there is this type erasure that is involved in stud function, which I don't want to talk about. It's kind of advanced, more advanced, but just for completion, there is also stud function. Yeah.
Okay. Thank you, Kobe.
Hey, Kobe, the add pointer is introduced in C++ 14 or?
Yeah, add pointer, actually, I think, if I'm not mistaken, this is 11.
Okay.
I think the underscore T was 14, but let's see if my memory is correct.
So underscore T stands for type, right?
Yeah. So this is 11. And yeah, in 14, they added this syntactic sugar. So you don't need to do, so I could do something like this. Which is, it's just a syntactic sugar. And by the way, if this looks scary, don't worry. This is not the main thing in this. It's kind of a mixture of beginners and more intermediate. But yeah, so these two are.
When you say colon type, does it mean that it refers to a type or a declaration type?
So inside 8 pointer, there is a type def of type to something, and I'm actually referring to this. This is a type trait. It's a very interesting topic that we should probably have a session on. I think type traits are super important. This is why I have this. Okay, let's continue. Okay, so in C++, I'm gonna argue that the lambda in C++ 11 and above, they are no more than just syntactic sugar. That you can have everything that you need done even without C++ 03 or 98. You just need to work harder in some sense, and it's uglier. Just a lot of boilerplate code that Lambda helps us. So in C++ 03, you can, in 98, in C++ in general, you can have this special callable object. What does it mean, callable object? So callable object can be a class or struct. It has a name. Just you have a class foo. And the way, so this should look like a regular class. You open parentheses and you close parentheses. And there is this callable operator, which is operator parentheses. And it's kind of confusing, I know. So this would be the syntax of this operator. So this operator parentheses looks like this. So this is the operator. And in parentheses, we have the arguments. Let's say int, character, float, whatever the argument is. There is a return type, and there's the body of the function. So should be. So here's an example. So let's open Godbolt. This is an example of a simple callable object, and the name that people used to use was functor, function object. I'm not using functor anymore. I just call it a callable object. And again, what you need to understand, this is the return value. This is the name of the function. The whole thing. It's confusing because it has parentheses, I know, but this is the name of the operator parentheses. And then these are the parameters. And in 98, what I could do is I have this print functor 1. I could actually pass this to a function. So for each is a function that the third parameter, it's a template function. The third parameter is requesting a function, a callable object, that is. So if I would need to write my own for each, this would be something that I could write. So the for each that is on the standard would look very similar to this. Just ignore the templates right now. The templates, it's outside of the scope of this, but templates are everywhere in C++. And it allows me to pass a range, first and last. So this is a range, and I'm passing some callable object. And the idea behind this callable object is that I can take this instance and I can treat it as it was a function call. Okay, and I'm taking this function, and I'm passing the first element, the first element, and then I increment. So I basically, if you look at what this for loop is doing, it takes each element and call the function on this element. So I have a vector of integers, and I have a range from beginning to the end. So I have 2 elements in this case, and I'm passing this instance, and this instance have this callable object. And when I pass it and this function call is being invoked, it's using this operator and it's passing something. This something needs to be known at compile time. The type needs to be known at compile. So if I put something else here that this code cannot handle, I'll get an error. Okay, so I'm expecting an integer. This callable object expect an integer. And what I'm just doing stud cout x and then flash it. It's a bad habit to flash it, but it's just an example. It costs money and time and all, so you don't want to. But it's just for an example. So I can see that I'm running this code and I'm getting this 1, 2. Now I'm running the same, almost the same code. So for each and for each, but now I'm taking this functor 1, I'm defining a functor 2, which is the exact same thing, but look, it's not on the global space or something, it's inside a function. So first of all, this is a new thing. You don't really need to remember that, but just as a FYI, this is something that was added to C++ 11 that we can actually create these types inside functions, and then we can use it. If I try to compile it with 03 or 98, this would not compile. You'll need to trust me on that one. So I'm doing the same thing. This is the same code, but it just shows you a new way to put this type inside. I'm creating an instance of it. By the way, this should also work. It's the same thing. Using curly braces, but yeah, I need to do this. And this is just my for each that I talked about with, and any of this would work. I just wanted to show you that there is no magic in the stud algorithms when you pass a function or a callable object, and Lambda is a callable object. This is what I'm shooting for. There is no magic here. Any question here? Because this is it's a significant part to understand Lambda.
Yeah, quick question. I mean, it's not really relating to the functors and whatever, but it's more as to like you're passing in iterators. But I remember last time you mentioned that you want to use it's better practice to use begin parentheses, the name of your container, and then right parentheses.
Yeah, because it can work with C arrays that the size is known at compile time. I know. In this case, I know it's just an example. But if I wanted to have another one, let's say a V, which is an integer array of, let's say, 3 or 4, 10 elements. There is no v.begin. Let's say it's a v1.begin, but stud begin on v1 would work. Yeah, okay. But you'll see that both of them stud begin would call v.begin if such function exists. Otherwise, it would try to extract the size of like the pointer to the first element of a C array. So there's all kinds of template metaprogramming, which I don't want to go into right now, but that's the gist of it. Any other question? Okay, so let's continue. Yeah, I explained that this is basically how things would look like in C++ 11 and above. You can have this functor inside. Yeah, this is just repeating what I said. It's not going to work with 98. You cannot instantiate the template for each with a local type. This was gone in 11, so we can use, we can support Lambda, which is basically anonymous names, callable objects. Basically, I found out that it's warning on Clang. There's an error on GCC. I checked both on the trunk. Okay, so I mentioned that before we dive in, Lambda are just kind of important syntactic sugar to 9803 way of constructing callable objects. It just greatly improve our productivity, readability. Yeah, once you get used to it, initially people look at Lambda and they freak out because it looks very, very strange. The nice thing about Lambda, if you take everything that Lambda support, and Jason Turner had an episode on that, or a few episodes on that, you basically would have every single thing in the standard baked into Lambda. So if you know Lambda well, you'll know a lot of things in the standard are kind of exercised into Lambda. Okay, so let's dive into C++ 11 Lambda. So the structure is very, at the basic of it, it's very, very simple. It has a capture list, and I'll explain that, and then the parameter list of the callable object. This is, if you think about function, this would be parameters of the functions, and then the body. Okay, it's very kind of a straightforward syntax. There is these optional things that I'll explain, where you can have mutable, no except, training return values. I'll talk about it more in future slides, but this is the very basic structure of Lambda. And if we take a step further, you can see that I'll explain what does it mean equal. But just ignore this equal for a moment. There is this parameter list. So this callable object expects an integer to pass as a parameter. There is a mutable, and I'll talk about mutable. There is throw, basically no except is the right thing. And there is return type. And I'll explain why it's optional, when it's not optional. And this is the body of the function. It's just the body of the Lambda. And it can be multiple lines. I suggest you keep your Lambda short, but it can be 100 lines. Of course, doesn't matter. It's just the body of a function. But keep it short, so it's readable.
Hey, Kobe, one quick question.
Yeah.
The arrow you are using there, right, before the int, is it an optional or it should be mandatory?
It's optional. It's optional. I have a few slides on the return type, and I'll explain when it's being used. I'm barely using it unless I want to force something, but I'll talk about it.
Sure, thank you.
I don't remember the last time I used the trailing one before. I used it in template meta programming where I needed to do some stuff, but 99.9% of my lambdas I don't specify. The compiler knows what to return. It can infer from the body, and you don't need to.
So we need that only for specifying the return type.
Yes, and again, I would advocate to leave it to the compiler unless you really want to force something else.
Sure.
And again, I'll explain in future slides.
Thank you, Kobe.
Okay, so should be C++ 11. Sorry, this should be demystifying Lambda. If I have this Lambda where I have, forget about the capture right now, just parameters of to the Lambda, which is basically this would be the function parameters, and then the body of the Lambda. This should look very, very similar to what I showed you in the previous slides. So it would look like this. What roughly would look like this, and I'll show exactly how the compiler sees that. But these two are equivalent. They do the same thing. Is any question? Because this is really basic to understand how Lambda works. And just as a side note, I'll explain it in future slides. This part where I don't capture anything, I'll explain what capture means, also makes this Lambda stateless. Okay, it doesn't capture anything. It means stateless. Okay. So good. I have a syntax of the Lambda, but I want to use it. So basically, I want to create an instance of this Lambda, and I want to use it. I want to use it as a function call. So that's like a callable object. So here's a very generic way that you would use your Lambda. You would have auto. And why auto? Why can't I have a name, like a type name to this? Is because this type generated by the compiler. So the compiler would generate a type. So in C++ everything has a type, but it's a strongly typed system. So I showed you this. So this some instance, there's going to be a name that compiler name for the type of the Lambda of this struct or class. And this name is something that the compiler makes up. Okay, and there's an example here of some long name. We don't care. We put auto, which means, look, we don't care about the type. It is strongly typed. We don't care about the type. Just infer it from the type of the right-hand side of the equation, side. And this is the name of the function of my Lambda instance. We call it functor class. This is the capture class. This is the whole Lambda expression. This is the value, and taking the value +5. There is no return type. The return would be an integer because this is an integer. This is an integer. The whole expression is an integer. So the return type would be inferred as an integer. Okay, let's take a look. Okay, so I have very simple, you can ignore the warning because I'm not using this, I have this extra pedantic and all that stuff. So I'll start by saying that I encourage you to use Lambda. They are very thin. Lambda, they themselves are very, very thin. And if not a lot of things are zero cost abstractions, Lambda would mostly be a zero cost abstraction. I don't really remember a case where I put it on Goldbolt and I didn't see that the whole thing was optimized as if it was just handcrafted. So here's all kinds of ways to define lambdas. And I'm using const because I'm not changing the Lambda instance. I don't know what the type that the compiler would create. So this is the simplest Lambda that you can have. It doesn't capture anything, no parameters, nothing in the body. So if I call F1, nothing would happen. It's like a no-op because there is no return. But it's a Lambda, okay? And I'll tell you a secret. There is a way to have it even shorter. If you don't have anything to pass as a parameter, you can actually remove it. It's not mandatory. It's actually optional if you don't have anything. So this is actually a shorter Lambda. And this is really the minimal Lambda that you have. Okay, and again, I can do something like F2. There's a no-op, doesn't do anything. Very, very simple. Now, I can also initialize, it's going to look the same where I pass, like I put it parentheses, okay? It's the same thing. The same code would be generated. Or I can put it in curly braces. Same deal. It's going to initialize F4, just like F3, and so on and so forth. In this case, it doesn't matter. This specific syntax, this exact syntax doesn't matter. Okay, now what I'm going to do is I'm going to pick one of them. I want to show you how the compiler would look like, would see that. So I'm going to click on this CPP insight. And you can remove all of that stuff. We don't need it. And I'll click play. And this whole code is being generated. Okay, so let's take a look. It looks scary in the beginning, but it's very simple to understand. So we have a function main. That's easy, right? Starts here, ends here. And what I can do actually, I can take that. Okay, so I have this main function. And then I have this class. And this class has a name. Underscore lambda underscore 2 underscore 21. Okay, so so this is a Clang, sorry, an LLVM AST output. I noticed that the lambda would have this, the 2 is line 2. I just noticed that it's always this part, so it will be underscore lambda underscore the line where the lambda starts or define, and I don't know what this 21 means. I don't know where the 21, but I noticed this 2. You don't need to worry about it. It's just if you're interested in, hey, why this 2 and all. I just realized that lately looking at this AST, I just realized. So it doesn't matter. There's just a class name. This is the type. It starts with 2 underscore. This is why we should not use underscore, double underscore, and all of that in our own code. It is kept for compilers and standard library authors and all of that. We should not use it. I use the trailing one. So this is public. If you know classes in C++, there is access specifier, there is private, there's public, there's also protected. So public interface means that we can call it. Just ignore all this. I'm gonna just remove it. So it's confusing. This should look very, very common and familiar to you after the previous slide. This is the operator, the callable operator, and this is the name of the operator. Should not be surprised right now. And there is no parameters. Just ignore the const. Inline means it's inline, but just ignore it. But you can understand that lambda, by just writing this very simple syntax, the compiler created all of this hard, like this boilerplate for me. Some people say in joke, like they kind of joking that this is like lambda are like macros, but even though it's recorded, don't quote me on that. Lambda, they're not macros or something, but if it helps you to understand, there is a boilerplate the compiler creates for you. Okay, now there's all kinds of other stuff happening here, and I'll explain it very briefly. Well, we'll talk about it later. This should not be a surprise for you, because if you remember my first slides, this just defines a pointer to a function, and the function is returning void, just like this, and no parameters. Okay, and there is this operator that is defined. I don't want to elaborate on that, but basically this is a cast operator. Long story short, but this actually allows us in specific lambdas, which are non-capture lambdas, so lambdas with the capture empty, they can be treated as C functions. Okay, so remember that. We'll talk about it in the more advanced part of the workshop, but just think about it as a bonus that we have, that we can actually take this whole class and decay it into a simple C function pointer, which is really nice. Think about, I want to interact with a C function that doesn't know C++ and all of that. I can decay, if it's a lambda without capture, I can decay this lambda to a simple C function and pass it to a C API. It's a bonus, but doesn't need to worry you for now. So this is the whole story. What you should see is that there's boilerplate code that was generated, and this is the instance, and this is a function call. F1. Now I can take F1 and just invoke it just like a function, and all is good, right? That's it. That's the whole story of Lambda, and this is very important. So I'm going to stop here and just ask if there is any question regarding this part, because this is the most important basic stuff in order to continue. Okay, good. Okay, let's continue. So this would be the minimal ones. You see this plus sign before this lambda. This is where I can decay the function into a function pointer. This is a very tiny unknown feature in C++ that this plus before some types can decay the type. And this, by saying decay, there's going to be a cast operator, and I'll talk about it later, but just to tie the knots between what I showed you about this cast operator, this is how you interact with that. So this is the bonus part of Lambda. A non-capturing Lambda can be decayed into a C function pointer, and you can pass it into any C API that required a function pointer. If you ask yourself why I'm saying non-capture, why a capturing Lambda cannot be decayed into a simple function, when I talk about capturing, you'll get the answer. Just think about it a bit, and then we'll talk about it. Okay, so this is the CPP insight that I had. We can take a look quickly. So I'm creating 3 lambdas, so it's going to be lambda with line 4, line 5. And I'm creating instances, right? So this is the instance. Line 5, and this is the instance, and then line 6. And you can see that there is a static cast operator because I did this plus, and F3 is actually a function pointer. It's a function pointer which is using this cast. I'll explain that more later, but if you are kind of an intermediate plus, you probably understand this is a very nice bonus for us when using Lambda in terms of interoperability with C language.
Kobe, quick question. When
Yeah.
you use plus, it will automatically convert into a C code, or is it an optional conversion to C code?
Okay, so in some cases, a plus would be decaying a type to something else. So by putting plus in front of Lambda, I'm forcing this decay to a function pointer if the Lambda is non-capturing Lambda. So
even in a C++ 17 compiler, if I want
yeah.
It will decay.
Yeah, and if you just Google, I don't have a slide on that, but Google C++ plus sign decay, you'll get all the use cases where you can take a type and decay it into a pointer. If I'm not mistaken, if you take a CRA and put plus in front of it, you'll get it to be decayed to a pointer to like
pointer.
Yeah, so something along those lines. I can't remember, but just Google for that, and you'll see all the. You're welcome. Any other question? Okay. So I already talked about it, but just to kind of give the summary, these 3 ways to, and I'm using here just the trailing. Doesn't have to be, but I'm just using it, just an example. You can have an assignment, parentheses, and curly braces, just be consistent. I honestly started with parentheses because I saw it in books, and I slowly moving into curly braces. The square braces can be a blessing and a curse, depends on the context. If you understand what I'm saying, you probably know. And again, this would be deduced as double return value. Why? Because 2.0 is a double, and a is an int, and this whole expression would be promoted to double. If you want to know more about type promotion, I definitely encourage you to look at the same talk from Dan Sachs about integers, and I can't remember the exact name of the talk. But if you just Google Dan Sachs C++ integers, you'll get it as a first hit, if I'm not mistaken.
So here auto gives you what is the type of M lambda?
We don't know. We don't care. At least not here. We would care. We would care if we need to do something else. Let's say get another instance. Then we use decal type. But basically here, I don't care, and I don't know. And throughout my code, I would not be able to refer to the actual type. It would be always, hey compiler, I don't know what the type. There is a type. I don't know what the type. I put auto, and you'll take care of the type for me, because I don't know what kind of a type you came up with.
Okay, because in the beginning of the chapter you talked about function pointer, right? So I was wondering whether M lambda will be a function pointer or
no. They're not function pointer. They would look like, where is it? Where is my, 1 second. They would look like this.
Okay.
And if you're interested to see what happens if you do this lambda or that lambda, put it either on Goldbolt and click on the CPP inside, or just put it on the CPP inside directly, and they have also a link to Goldbolt, so you can see that it's both ways, which is really nice. I use both of them on a daily basis, by the way, just to see what the compiler is actually seeing when it's tokenizing this whole thing, and give me the output of the AST. Okay, so let's continue. So, kind of closing the loop, these two functions, where I actually using my own handcrafted operator struct, which I needed to use before Lambda were introduced. Or when Lambda introduced, I can actually iterate and provide. So here's again, the for each is iterating over the vector. So takes one, pass it to this function. The function is this Lambda is capturing nothing. This is the capture, it capturing nothing. It passes, there is a one parameter to the Lambda, it's integer, and this would be the Lambda body. Now, I like to simplify my stud algorithms syntax, and even though I'll use 2 lines, it would be optimized and all, so don't worry. I actually like to put my Lambda in a different line. And again, you can put parentheses or curly braces here. And I put my Lambda, and I have lots of spaces, so you can easily see the Lambda. I don't know the type. I named the Lambda F. It's a bad name. Make a useful name. For example, print me would be a better name here. And for each is basically just a loop, which takes the vector content. Print me, what did it do? Still compiling. And it's just printing the value of that was passed. So 1 and 2. So I have 3 of these. One would be this guy, which is my handcrafted. One would be the second one, which is I'm using the Lambda directly into the for each, because for each has three parameters, begin, end, and a callable object, so I can put it directly. It's equivalent to have them in different, and I really like to name the variable of the lambda, because I don't need even to look at how I'm printing, because I have a print me, and print me or print int or print whatever is a meaningful name, and I don't need to look at the how. I just need to look at what it's doing. It's just printing. I don't care about the how. While here there is this, it's cluttered with the actual details of what I'm doing in every iteration. So I encourage you to separate this. Okay. Next. Okay, capture list. So think about this scenario that, let's take a look at Godbolt. I have this requirement, I have this struct, and I have this requirement where I want to pass something to this. So remember, this callable object is a struct slash a class, which for us, it's the same thing. A struct is all public, while class, the default is private. So I have this integer. It's a member function. It's a data member, sorry. And I have this member function that you should already be familiar with. It's the same one. This is a callable function operator. There is one integer that I'm passing. There is a const. I'll explain about const in a moment. And I return nothing. And I have a constructor that takes x. So what I'm doing here, everything that you give me. So I'm initializing this instance with something, and everything that you give me, I'll time it. So if you give me, okay, so I have this vector, and I have this some instance. I'm creating the instance, and I'm passing 10. So I have an instance in memory that is populated with the number 10. Now, every time I pass a function, I pass a number to this function, the number is passed here, and the body of the function takes this x and multiply it with what I already had before, which is a fixed number, in this case 10. So what did I do? I basically, everything that I pass would be times 10. So if I put here 3, 4, or maybe 10, then 100, I would see this 10, 20, 30, 40, 100, and 1000. Okay, is this part clear? Because what I'm doing here is just creating this vector and creating this instance. I'm getting it like it's just a very common way to create an instance in C++. And you don't need to heap allocate. It's very simple. And yes, I could do something like this. If you ask, I can do some instance, and I can pass it. It's just a variable, but it's a very special variable. It has this operator parentheses. So okay. Here's like a callable object. So once you wrap your head around this whole callable object and how it looks like at the guts of the system, you should be cracking any lambda on Earth, because it's all start and ends in this function that is it's an operator, okay, and it makes my instance or my type to be a callable type. Any question here? Because this is super important to understand capture. Okay. Okay, so, oh wait, I wanted to show you. The CPP inside just to show you how it looks like. Basically, you can see there is nothing special here. All looks very, very familiar to you. Well, the whole std cout and all looks a bit weird, but just ignore it. Okay, so why we have a capture list? So there are a few reasons. One, as I mentioned, I wanna do something with a fixed, like I'm fixing something. In this case, number 10, and every value that you pass me in my callable object, I'll take this 10, which is a fixed number, and I would time it in with the number. So that's one thing. Another thing that is important is to be able to access elements that define outside of the lambda. So here's an example, and I'll explain in details each of them. So capture by reference, you can do two things. You can capture variables and instances outside of the lambda by reference or by value. Now, when I say capture, and I'll show you an example, just imagine for a second a lambda that is referring inside the body of the lambda. It's referring to an entity that is defined outside of the lambda. So if I capture everything by reference, it's like I have a reference to this element. Okay, if I get any element that the lambda needs, there's some exceptions, but just for this example, for this slide, think about everything that I refer in the lambda would have a reference to the outside entity. If I use the equal sign, it would capture it by value, so it would make a copy inside the lambda. Now, these two methods means everything that I need in the lambda would capture by reference. Everything I need by the lambda would capture by value. Like make a copy if you can. If you cannot make a copy, there's an error, of course. But the best practice would be don't use it this way, but be explicit to what you would like to capture by saying, I want to capture X by value, so make a copy of X. So there is some X outside, so make a copy of that. Oh, there's a Y outside of the lambda, make a reference to it. Or maybe capture both of them by value. So this would be the X and Y. And the idea is, again, the compiler looks inside the lambda and say, okay, I need X, I need Y. Did you capture this for me? If not, I can't access it, so I need your help. And when I say need your help, the compiler needs our help to access these elements. Let's take a look at a few examples. Okay, so I have this X and Y, and I'm printing them. And then I have a lambda, a very simple lambda, and I'm referring to this. Let's take a look at the gold bolt. I'm referring into these two. Let's do this so it's easy. So you see that I'm doing plus plus X, plus plus Y. So if I don't have this X and Y, I would do this. Oh, okay, I need to create this lambda, and I have this X and I have this Y. Hey, what is this? There are two ways that you can supply this X and Y. Two ways. One, they can be parameters. So if I pass X and Y, they'll do plus plus X and plus plus Y. Of course, this doesn't make sense here. There is nothing because we pass by value. I can have it passed by reference, and it would be more meaningful. But at least the compiler would not be angry and say, "Hey, I don't have this X and Y." So this is one way to satisfy the requirement that you have this X and Y. You need to be referring to them. The second part. The second way is the other option is to capture it. So there are a few ways to capture. I can do this, which means tell the compiler, hey, you have X, you have Y, just everything that is in the enclosing scope that you can find X and Y, just capture this for me. Okay, and it doesn't compile. I'll explain why. The reference would compile. I'll explain. It's a different section in the presentation. So you can see that I'm printing 1 and 1 because I'm initializing X and Y. So I'm printing, and then I'm calling this callable object, and then it will be 2 and 2. So I actually really holding references to this X and Y because I changed the Lambda changed it. When I call the foo, I change, like if I don't call the foo function, oh, it's just a callable object, it should be 1 and 1, right? Because I haven't changed anything. Yeah, it says I'm not using it, but it's 1 and 1. So what actually happening inside this Lambda? And again, I can do, the best practice would be telling the compiler, I actually want X and I want Y. By ref. So let's take a look what the compiler actually sees. And we take another 10 minutes and we'll call it a day. We're kind of a bit over time. So this is let's just ignore this whole thing because I just want to take a look at the generated. Okay, so int X, int Y, std cout or std log in this case. Forget about it. It's a funky syntax, but forget about it. Then Lambda. We know, again, line 8, because the Lambda is 8. I just noticed that. This is the body of the Lambda. Should not be surprising because we already know that. Now take a look what happened here. I actually have a state in the Lambda. Like I have members. This is a new thing. This is a new Lambda. Every Lambda that we had so far didn't have capture, right? It was empty. And we didn't have any data members, private, public, doesn't matter. We didn't have anything. And take a look at the constructor. We actually have a constructor that I pass this X and Y, and I assign these references to the X and Y. If you look closely, there's a lot of boilerplate that we saw in the non-capturing that went away. In other words, the whole bonus of being able to interop this Lambda type with a C API that is requiring a function pointer, a simple C function pointer, this is gone, right? And just think about it for a second. A C function doesn't have a state, right? It just have a body, and that's it. And here there's a state. Like you can't pass this as a function pointer to a C API because there is no such thing as a state. There is no class. There is no all of that stuff in C. So the compiler cannot generate this bonus feature of this Lambda for us. Now, this should look very, very familiar to you when you create, let me see 1 second. Yeah, you see this? You see this? This is the exact same thing. I have a constructor that takes this in. Here I make a copy. But this is I bet you're doing it on your daily basis when you create an instance. Forget about this operator, but you pass parameters to the constructor and you make a copy, or you keep a reference to the past parameter. You do it every day. So there is nothing special here because the compiler is generating this boilerplate for you. So the way to read this Lambda is that, oh, I have a class and I would have 2 data members here. There are references to something, and what the compiler is doing for me is it's passing for me this X and Y to the instance. So this foo would be a class, and the X and Y would be initialized to 1 and 2. And what I'm doing here is ++. So what happens when I do plus plus to something that I holding by reference? It will just increment that, and it's going to be visible outside of my lambda, right? Because I'm pointing having a reference. Now, just a side note, I'll explain that again. Nothing is prolonged here. The X and Y are not prolonged. They're just references, just plain references. This is not Rust or something like that. There's all kinds of special helpers from the compiler. They are not prolonged. If this X and Y goes away, you are basically, so if I do something like this, let me think if I can do something that no, I cannot do that. I need a different example. But if the X and Y goes away, in threading, like it's easy to do, by the way. I can have a thread that runs the lambda, and this function goes away out of scope, and that's it. But just forget about it for a second. The important part is that this whole capture is very, very simple. Now, if you remember, when I tried to do the following, I tried to capture both of them by value, and I had this error. You increment a read-only variable. Okay, so let's just not increment. Let's do something else. Let's just return x plus y. So let it compile, because I'm not actually mutating any of the x or the y. Okay, so nothing. I'm not changing it. You can see that it's still 1, 1. And let's take a look at what CPP inset looks like. So they are these are the original. Now they are not references in the class, and I'm just returning x plus y. You can see that the return value is integer. Now, do you see this? This one means that when I enter in this function, this x and y were as if they were as if these two variables were as if they were const. When I'm inside this function, this is what the const mean. Okay, let me see if there is any question. Return the lambda referencing the local function parameter. Yeah, that's also so Antoine saying an example of how to show this this thing is not prolonged. Okay, just to finish this section, you just need to remember that by default, this is one of the only thing that happens, good things that happen by default in C++, that it's const. So if I want to mutate both of them, I can do this or this, doesn't matter. This would not compile, right? Because I'm trying to increment a read-only variable. Remember, x is a const. So remember, initially when I showed you, there's all kind of optional part here in this part. Mutable is one of them. And mutable would actually, it's the exact same class, but it's going to remove, see. Yeah, I discard, yeah, because I discarding the, okay, we do this. Agree about this. So if I run this, okay, it's still not happy. Let me see why. I have a typo or something in that. Don't really. Oh, yeah. Sorry, I'm doing const here. So, yeah, if the function is const, I cannot call a function, a member function that is not const. Okay, so let's take a look how it looks like in CPP Insight. And in CPP Insight, you can see that the const is gone. Again, if I was having a const function, a const foo, calling a function, which is basically calling a member function, should be only a const function. That's it. Okay, so let me see how many I have for this capture. This slide I have it again, so I'll skip it. And I have the globals. I'm just thinking I'll probably stop here and continue because it's the section is not still does a lot of things. So let's do this. Let's wrap it up right now, and we'll continue next time. So I don't need to rush it and all because they're important things, and it's already 8:14. Any questions so far? Okay, thank you for attending. I'm sticking all the way to 8:15, which is pretty late. I'll post everything online, and we can continue discussions either on Slack or I think Slack right now is the best thing for us. Take care and have a good day.
Thank you, Kobe.
Thank you.
Thank you.
Thank you, Gobi.